Hello, good morning, good afternoon, or good evening, wherever you are on this beautiful planet of ours. Welcome to Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable carbon neutral society, and I'm your host, Mitch Ratcliffe. Thank you for joining the conversation today. The global food system is one of the largest contributors to greenhouse gas emissions, and it's responsible for about 25% of annual anthropomorphic CO2 emissions, the unfortunate planet-warming exhaust of our industrial society. But what if we could eat our way out of the climate crisis? Our guest today is Mark Easter, author of The Blue Plate, A Food Lover's Guide to Climate Chaos. His book explores how we can change our diets to help restore the environment, and he gets to the root of the challenge. As an ecologist who has spent years studying the carbon footprint of food at Colorado State University, Mark connects the dots between what we eat, how it's produced, and the impact on our planet. In The Blue Plate, Mark plumbs the concept of regenerative agriculture and carbon farming, showing how these practices can not only reduce the carbon footprint of food, but also actively restore ecosystems. From the smallest urban farm to sprawling agricultural lands, he argues that how we grow, process, and distribute food holds tremendous potential for climate solutions. It's not just a problem, it's the path out of the problem. For instance, he reports on the innovative use of cover crops and perennial grains like kernza, which has been shown to pull carbon from the atmosphere and store it in the soil, effectively turning farming into a climate-positive practice. Mark's journey from greenhouse gas accounting to becoming an advocate for low-carbon meals is filled with fascinating insights into how the food system shapes the world we live in and how, with the right approach, it can help reverse some of the damage done to the environment. You can find Mark Easter's book, The Blue Plate, A Food Lover's Guide to Climate Chaos, on Amazon and Powell's Books. We'll have links in the article that accompanies this podcast. So get ready for another in our recent series of important conversations about the future of food. But first, enjoy this brief commercial interruption, and then we'll be right back to talk to Mark. Welcome back. Now let's get to the conversation with Mark Easter. Welcome to the show, Mark. How are you doing today?
Hi, Mitch. I'm doing great. Thank you so much for having me.
Well, thank you. You know, you started your career focused on the carbon footprint of food systems as an academic, but I'm wondering, how did writing the book change your thinking about the challenge of feeding humans within global planetary boundaries?
Yeah, boy, that's such a great question, and I think a really important one. Writing the book really was a journal of discovery for me. I'd been embedded in a research team trying to understand, what the greenhouse gas emissions were from producing food, from processing and shipping it, dealing with the leftovers. And we were focused on a relatively narrow aspect of the carbon emissions that come from all of that. And I realized that in order to really capture this issue well, I was going to have to expand my view.
Mm-hmm.
And so, and as soon as I settled on the framework for it, which was a plate of food, just imagine a dinner party, a weekend dinner party, and what might be served there, where you might have, say a fish appetizer or a soup, let's say a chowder to start the meal. Let's see, a salad, a bread course, a beautiful roast or chicken casserole or something like that. And then a dessert that maybe involves some fruit. When I started examining all of that in total, I realized I was going to have to expand the boundaries of what I'd been looking at. And that was eye-opening for me. There were a lot of surprises, particularly when I started looking at fish. So let's say one of the really surprising findings was that there are types of fish that show up on the menu that have extremely low carbon footprints and others that have extremely high, and a broad range in between. And also, I was just surprised. I had read some pieces about this, but I was surprised about the impact that aquaculture was having
Mm-hmm.
on carbon emissions, and the way that we're raising seafood rather than just capturing it from the ocean like had been done up until 40, 50 years ago, when aquaculture started to come in to replace, to basically meet the growing demand for seafood from humans. And so it was just that journal of discovery process was enlightening. It was wonderful. It was concerning, frightening in some cases, where we have this saying within our field that this work is like trying to understand greenhouse gas emissions and doing these inventories in the food system. It's like peeling the layers of an onion. And the more layers that you work down through, the more interesting it becomes. But also just like, peeling the layers of an onion, sometimes it makes you cry. That's
Let's use the example of a low carbon fish, such as a sardine. Even though it's low carbon, those fish, those pelagic fish, as compared to, say, tuna or something like that, in the context of global warming.
Yeah, it's really interesting. So I spent a lot of time for the book, looking at farmed fish versus wild caught fish, looking at things like sardines that are direct human food, but also sardines are used to feed other fish that we're growing in net pens. Let's see, it's a really important food source for farmed salmon, let's say, for example, and other sorts of farmed fish. There's this big distinction there. Those sorts of fishes, sardines and other small fishes like that, are food for wild fish. If you're going to feed them in a pen, which is essentially the seafood equivalent of a concentrated animal feeding operation, a CAFO, you've got to go out, got to motor out, catch these fish, bring them back, keep them cold, process them, essentially create fish food out of them, and then transport that. And oftentimes the supply chains are thousands of miles long.
Yeah.
And bring that food back to the sardines or menhaden or anchovies or herring or whatever it might be, back to the where the fish are being raised. So that's a big source of emissions. Contrast that, and in addition to that, for aquaculture, the base for most aquaculture feeds now are corn and soybeans.
Yeah.
It's fascinating, just like, and that's the same base food for raising beef or chicken or pigs and CAFOs. And it creates greenhouse gas emissions, the process of growing those feeds, processing them into feed, and then shipping them to the CAFOs to feed to the animals. So those are significant sources of emissions. One of the things that was most surprising for me, though, was that the lowest source, or the lowest carbon source of animal protein, was shellfish. It's mussels, oysters, scallops, those that are farmed. And that was just fascinating to me. It's less than a pound of carbon dioxide equivalents per pound of the fish.
How is that the case? Because I have lived in the Pacific Northwest where oysters are farmed, and it is very much a natural undertaking. But why is the footprint so much lower?
Yeah, it's so fascinating. The first thing is that they don't have to be fed. They're being raised in an environment where, yeah, the environment is feeding them. It's the equivalent to wild oysters and wild mollusks,
Mhm.
other mollusks. Um, but then also the other thing is that they are literally pulling carbon dioxide out of the atmosphere and fixing it in their shells. They're creating limestone, they're creating rock from atmospheric CO2. It's through the process of establishing these shellfish farms, and which are functionally, they're providing this wonderful ecosystem service. They are helping to clean the water in the estuaries where they reside. Um, and in many ways, it's very restorative for these areas. And so they're essentially they're doing carbon capture, if you will, in order to create the
Yeah.
food. Yeah, that's wonderful.
That's really interesting. The idea that when you net out the impact of growing the animal growing, in that case naturally, as even in the context of a aquaculture, versus the farmed food, which brings all the material in and stuffs the animal, and
Right.
then we slaughter it. It really paints a very bright picture of the challenge. So, what would you suggest we prioritize in our agriculture and aquaculture in order to overall reduce our impact on the planet?
So in aquaculture, one of the things that we're finding is that in order to raise the most common types of fish that are farmed, and one of the most common ones is shrimp, we're finding that shrimp are raised in ponds that are very commonly put into what formerly were mangrove swamps,
Mm.
mangrove wetlands. And mangroves are some of the most carbon-rich ecosystems on the planet. In many cases, they have more carbon in them, if you can imagine this, than the redwood forests of the
Mhm.
Pacific Northwest and other temperate rainforests. It's really extraordinary. You go in and you clear a mangrove wetland, and there are tremendous carbon emissions that come from that. All the carbon that's stored there gets consumed. Frequently it's burned, but it gets consumed by microbes. It
Mhm.
decomposes away and it becomes carbon dioxide in the atmosphere and other trace gases. And then you create a wetland there in order to produce a man-made, an engineered wetland there to produce the shrimp. There's carbon emissions associated with that, and those shrimp have to be fed the same way that salmon and other aquaculture crops are being raised. So there's emissions from that. And ironically, in doing that, in clearing those mangroves, you're essentially replacing the ecosystem that formerly was the shrimp nursery. And so you're substituting one process for another here that ironically leads to very high carbon emissions. And so what I'm seeing is a strong push to actually move those out of the mangrove wetlands
Mhm.
to push for restoring mangrove wetlands to the extent possible and try to move towards a more sustainable system, maintain these critical ecosystem services that we see with stronger storms, with sea level rising. Mangroves play this really fundamental role in protecting shorelines, protecting the people that live in these areas, and making those communities more resilient as opposed to less resilient with the production of shrimp in these areas.
Now, in the book, you discuss regenerative agriculture extensively. I'm wondering if you could just initially share your definition of regeneration. Is it a matter of fixing the food supply, or is it even broader?
Yeah, thank you for that. That's a great question. And what I hear consistently from farmers, ranchers, and from the policy specialists, extension specialists that are working in this space is that regenerative agriculture is really focused on improving soil health and maintaining soil health. And soil health as a term is essentially a surrogate for increasing organic matter in the
Mhm.
soil and trying to maintain it there. What we find is that the more organic matter you have in the soil, the more resilient the ecosystem is, the better it is at cycling the nutrients in that the plants, the crops, the forage plants need, whether it's a pasture or a soybean field or whatever. And so increasing and maintaining the organic matter in the soil is really a principal focus. It's not the only focus, but it's a principal focus. And by doing that, we're pulling we're pulling carbon dioxide out of the atmosphere as through the process of photosynthesis and managing the soil, managing the crops in a way that we increase the organic matter. We essentially transfer that plant matter from the crops, from the pastures, back into the soil. The soil is one of the largest pools of carbon on the planet. There's almost twice as much carbon in the soil as there is in the atmosphere today. And it's fascinating. It just is, I think, an example of just how much capacity there is there and how much more could actually be stored in the soil.
A lot of the book is influenced by your farmophilia, your love of farms. Can you talk about how regenerative agriculture is a grassroots movement? And particularly, you tell a story about Curtis Sales's 5,500-acre farm and how it became an ecosystem restoring service to the environment. Talk a little about that. How did that happen? And what were his business results, for lack of a better way of describing it?
Yeah, you bet. Curtis Sales farms with his son-in-law and their families in eastern Colorado near the Kansas border, near a town called Siebert, Colorado. They grow dryland crops, meaning it's not irrigated, and
Mhm.
it's one of the most challenging places to farm in the world. They get 10 to maybe 11 inches of rain per year on average, and it's highly variable. They might just get a few storms a year in order to provide the moisture for their crops. Curtis had been farming for a long time, and what he said to me, which really stuck with me. He said, I've been farming the same way for years and years, and I was having a harder and harder time making it work. And I realized my soils had hit rock bottom. And that was interesting, that phrase, my soils had hit rock bottom. He was paying careful attention to his soil, and that's really the heart of his farm. And any other farmer or rancher will tell you it's all about the soil. And he said I had to just do things differently. He and another farmer to the north, Steve Tucker, and other farmers from their region, they have a peer network. They've been working together trying to essentially solve problems on their farms and improve their market conditions so that they could sell at better prices. And they realized, wow, we need some help trying to figure out how to improve our soils in these challenging conditions. So they formed a group, they raised some money, they came to Colorado State University, where I worked at the time. And they said, look, we need help. Is there anybody here who can help us work on developing regenerative practices? And they formed an alliance with the university and got connected with a scientist, Dr. Megan Shapansky, who was an expert in cover cropping and regenerative practices.
Mm-hmm.
And so I think this is one of the most interesting stories in agriculture today. The farmers are really innovating around regenerative agriculture. They're bringing the problems to the academic community and to business, saying, look, we need to solve these problems. These are the things we're trying. So this alliance that they formed with CSU was around a farmer-led research project. Dr. Shapansky and others within her team and others at CSU worked with them to help them design the experiments, which they then implemented. They then ran, and CSU helped with collecting data and analyzing the data and reporting out the results. It's fascinating what they're learning from all of that in terms of how to pivot out of these incredibly destructive farming systems that they saw were just driving their soil organic matter and their profits into the basement, which was this fallow wheat system where they're preventing crops from growing for 16 months out of the year so that they can store up soil moisture to grow one crop, a single crop, typically wheat, for just 8 months out of the year. And in doing so, it's one of the most destructive practices that we know of for organic matter. Yeah, so they've seen really interesting, important results. They've diversified the farms. Curtis no longer just grows wheat. He's got 8 or 10 different crops that he's growing with a variety of different practices. And also, very interestingly, he's brought livestock back onto his farm.
Mm-hmm.
So he's grazing livestock in his fields in the shoulder seasons to graze down cover crops and to graze on the straw and the crop residues afterwards. And that's a very promising practice for increasing organic matter.
They poop and
Yes.
restore soil. And the other interesting thing is that their hooves actually help mix the soil. And there's a lot of interesting areas to dig into there. But the other thing I wanted to ask you about before we get to the commercial break is the idea of carbon farming. Farmers don't just produce a crop, but they can store carbon. What kinds of incentives are in place to encourage farmers to do so?
Yeah, that's I think a really important question right now. Both state and federal government agencies are working with farmers in order to provide incentives, to essentially provide resources to pivot to different types of farming practices or to modify the way they're growing their crops or managing their pastures in order to increase the carbon in their soil. And so one example is the NRCS, the Natural Resources Conservation Service. They have programs like EQIP and CSP and others that essentially fund farmers, provide resources to farmers to change practices, to help them get over the hump, typically funding in the range of 3 to 5 years, and they'll pay a significant portion of the cost, let's say to buy cover crop seed or to purchase new equipment, and also technical expertise, which is often needed for these sorts of things. It's not just the federal government, it's also state government. There are also voluntary carbon markets, companies out there that are doing similar sorts of things, but they are contracting with farmers to change practices in order to sequester carbon in the soil, increase their soil organic matter. And in exchange for that, they essentially take ownership of the carbon that is being accumulated in the soil, and then they sell that to companies that have an issue with greenhouse gas emissions, basically as an offset. And there are good and not so good examples of those sorts of things. And it's a new market out there. It's essentially a very relatively new concept. We're learning a lot in that space right now as people attempt to move that forward and make it viable.
This is a fascinating conversation. We need to take a quick commercial break. We're going to be right back. Now let's get back to the conversation with Mark Easter, author of The Blue Plate, A Food Lover's Guide to Climate Chaos. We're talking about how the human food supply can be redesigned to reverse climate change and restore natural ecosystems to allow all creatures to thrive. Mark, you write a lot about the idea of pharmaphilia, and you elaborate on this love of farms and how it influences your notions about climate solutions. How important is farming to the future of humanity? We've been encouraging people to move away from farms for the last 100 years and corporatizing them. Are we at a pivot point where maybe the family farm should make a bigger comeback?
Boy, that is such an important question. And I think one that really, where the climate crisis really connects to the plates of food that we have before us every day. We've been burning greenhouse gas, producing fossil fuels for a long time, at scale for more than a century here. And it's led to very large concentrations of climate heating gases, principally carbon dioxide in the atmosphere. What we've also found, it's fascinating to me, is that over the course of human development, the last 12,000 years since agriculture was first developed, that we've actually been releasing greenhouse gases into the atmosphere from the ecosystem, in clearing forests, plowing forest land and grassland to raise crops or to create pasture land to raise livestock, and also increasing the, just different sorts of farming practices. We're essentially moving so much carbon that was in the forest, in the grasslands, in the soil, into the atmosphere as CO2 and methane and nitrous oxide. And that's been warming the climate, or said a little bit differently, it's been keeping the climate from cooling for the last 8 to 10,000 years. We're at a point in essentially the orbital dynamics where we would be sliding slowly towards another glacial maximum right now. We'd be about halfway between glacial minimum and glacial maximum. But doing that has been increasing these climate warming gases, atmosphere concentrations in the atmosphere, to the extent that we're a lot warmer now. The climate is a lot warmer than it would have been without those practices. And that's been because of agriculture. To the extent that the amount of CO2 released during that process is equal to about half of the carbon dioxide that was released from burning fossil fuels. Now, most of that CO2 is not in the atmosphere anymore. It's moved into other earth pools or into the ocean. But it speaks to what the capacity is for returning a lot of that CO2 that comes from burning fossil fuels back into the Earth system, principally into soils. And what the research is showing us is that in order to prevent the climate from going into essentially the most dangerous space, where it would be really challenging for human society to continue, we have to draw down carbon dioxide concentrations. We have to pull it out of the atmosphere, get it back into the earth in some form. And one of the most cost-effective and efficient, and it's functionally sort of shovel-ready right now to do it, is through farming. We're finding that on a ton per ton basis, cost per ton basis, leveraging agriculture, farming our crops differently, raising our livestock differently, not just reduces emissions from the system, but it also has the potential to draw down carbon dioxide from the atmosphere into the soil. And on a cost per ton basis, it's half to a third to a quarter of what the costs are for the tech solutions, the direct carbon capture and other synthetic photosynthesis and other sorts of things. It's also, what we're finding is that it's essentially a no regret strategy for most farmers. because they see so many other benefits that come from this. They have the opportunity to use less fertilizer. When you increase organic matter in the soil, the soil holds more water. It has the ability to capture snowmelt and extreme rain events that we're seeing more common as time goes on. And by doing that, they can weather the droughts, the dry periods more smoothly. It stabilizes the variability in the cropping system and their yields, and many other benefits that come from this. And so it's not just a climate, well, it's mitigation on several different levels, not just helping prevent the climate from becoming worse, but at the same time helping agriculture become more resilient going forward, which is something we're going to need.
The other end of that food supply is us and what we eat. Can you, and this is, of course, what your book is about, can you tell us what the key components of the blue plate meal, a low carbon meal, we should be thinking about having regularly in our homes?
Thank you for that. So I conclude the book with a set of recommendations. And I think one of the most succinct one comes from Michael Pollan. In his book, In Defense of Food, Michael Pollan has this really succinct recommendation. Eat food, not too much, mostly plants. And I think that's probably sums up one of the core recommendations that are coming to us from regenerative agriculture and what we're learning about the emissions from how we produce food. And not just that, we've also found that there are, I think, interesting and important alternatives to the heavily meat-based diet that we have. We are probably at the point now where I just describe as peak meat. In order to, if we're going to eat more meat going forward, and I mean humanity as a whole, if we're
Right.
going to increase the meat supply for a growing population and a more affluent population, that means clearing more forests, plowing more grasslands in order to create the forage, to raise the crops, to feed the animals, or to allow them to graze. And this is at the same time where I think is pretty clear understanding that we actually need to increase our forest cover. We need to be restoring forest land and restoring grasslands in order to capture more carbon, for them to provide those ecosystem services we need going forward to weather the climate crisis and protect biodiversity. So finding alternatives to that I think are going to be pretty critical. And one example is pastured poultry, raising poultry in ways that are compatible with local ecosystems. And we find that poultry, and in particular pastured poultry, has much lower carbon emissions compared with beef and lamb and other sources of red meat. I mentioned before seafood, eating shellfish. If you don't have a shellfish allergy, it's a very low carbon alternative, less than a pound of carbon dioxide equivalents per pound of the shellfish. And that is about 1/60th of the emissions associated with eating red meat. Composting is a really critical solution going forward. We find that when we throw our food waste and our yard waste into the trash, it goes into the landfill where microbes consume it and produce methane as a byproduct. If we can divert the food waste from the landfill, get it into composting programs where it could be cycled back to growing crops, we're essentially recycling the nutrients and the organic matter in the food back onto the farm. We see a number of different benefits that are beneficial to the climate that reduce greenhouse gas emissions and help us to potentially sequester more carbon in the soil. Last two, eating close to home, avoiding foods that travel by air. So trying to shorten the supply chain. So from the 1,200 miles that most foods typically travel before they get to our grocery cart or to our restaurant plate, trying to buy from producers that are in your local food shed is really important. And then the last is, as verifiable labels for regeneratively grown foods are starting to become available, like regenerative organic, looking for those labels on the foods when you're comparison shopping in the grocery store is a good solution.
So there's a lot of details in what you just said and in your book that I encourage people to read. As you think about the historical failures of our agricultural system in terms of its ability to scale without heating the planet, what are the two or three things that we should really just stop doing now in terms of providing for the food supply?
Yeah, that's such an important question. I think the science is pretty clear that we've got to stop deforesting, in particular in rainforests and the tropics, in order to create more cropland to raise corn and soybeans and other forage crops for animals in CAFOs. It's destructive for biodiversity. It harms watersheds. We're starting to see that it's affecting the water cycle and leading to more intense droughts in those regions. It's just it's a difficult and destructive feedback loop that is frightening, besides heating the climate. So that's probably one of the most important ones. I think at the top level, we already have essentially placeholder programs in most developed countries and in many developing countries to essentially work with farmers to try to develop this sort of regenerative agriculture, the carbon farming programs that are practices that have been demonstrated to be so successful. And so expanding upon those, essentially doubling down on those programs so that there are more resources that go into programs that support farmers making these transitions, adding cover crops, reducing tillage, integrating livestock back into their operations, increasing the biodiversity on their farms, rotating their crops. These are the sorts of things that we're finding consistently reduce emissions from the farms, but also help to draw carbon from the atmosphere back into the soil. And so I'd say those are probably two of the largest ones at the 30,000 foot level. Looking forward, there are some moonshots I describe in the book. And one is a program started at the Land Institute in Salina, Kansas, where they're attempting to essentially perennialize agriculture, and they're succeeding. It's fascinating.
Could you explain perennialize agriculture? Because I don't think people are familiar with the term.
Yeah, perennialize means, currently if you're growing a crop of wheat, you have to go out and plant the wheat every single year. So you plant it, you harvest it, and then you come back and you repeat the following year. The Land Institute is trying to develop crops that can be planted once, just like prairie grasses. And they grow like prairie grasses. They develop deep root systems and they persist over the course of years or even decades. You plant it once, they become well established. They build a tight and dense web of roots in the soil, which helps to increase organic matter in the soil. They tend to be very resilient to weather variability, to droughts and intense storms. And you come through and you're still able to harvest once a year and potentially graze livestock on it. Interestingly, you can also grow these things in what are called polycultures. Rather than just having one crop at a time, you can grow two or more crops at the same time, and they get harvested. Seeds are of different sizes, so they can be harvested at the same time or harvested in different ways.
Interesting.
And then another is sort of restoring our love of essentially tree foods. Think of nuts, other sorts of, we get a lot of fruit from orchard and vineyard crops today, but expanding our network, our markets for those sorts of crops. The North American continent at one time was a vast storehouse of tree nuts that fed indigenous peoples, chestnuts, varieties of pecans, walnut-like crops like hickory, and really fascinating. And we've essentially mostly turned our back on those sorts of crops, cleared those forests in order to produce monoculture crops like wheat, corn, and soybeans. Restoring those forests or integrating them back into our cropping systems so that we are growing these foods that are very carbon rich in terms of the ecosystems that build them. These food forests has tremendous opportunity to pull more carbon out of the atmosphere and also and store it in the wood, and also help. They're really important for biodiversity and potentially for resilience for the food system going forward.
Well, and what you describe is a very diverse farming environment rather than these monocultural ones that we've come to know and drive through with endless fields of wheat or corn that block out every other type of living creature. Mark, this has been a fascinating conversation, and I encourage everybody to take a few hours and read The Blue Plate. How can folks learn more about your work generally?
Yeah, thank you. So I have a website. It's farmtablesky.com. That's farmtablesky.com. I've got a link there to the description of the book and just a short bio about the work that I do. I'm continuing to work at Colorado State University, have some initiatives going with colleagues there, which I'm delighted that that continues. And really active right now in discussions about the book. And I'm grateful for your interest and the public's interest in general. The book is selling well and a lot of conversation about it right now. Not just the Blue Plate, but this topic in general. There's just tremendous public interest, which has been a long time coming. It's really important, and I'm glad to see it.
Well, Mark, thank you so much for your time today.
Thank you so much, Mitch. This has been a great conversation.
That was my conversation with author Mark Easter, whose book, The Blue Plate, A Food Lover's Guide to Climate Chaos, is available at Amazon, Powell's Books, and your local bookseller. You can learn more about Mark's work at farmtablesky.com. That's all one word, no spaces, no dashes, farmtablesky.com. What if the path to regenerating the climate brought young families back to the land and healed the urban-rural rift that has emerged as lifestyles have diverged? For 125 years, since 40% of Americans lived on farms, we have discouraged youth from making their living tending the land. And now only 2% of the U.S. population farms. The result is depleted soils and fragile monocultures that are susceptible to drought and other extreme weather, which puts us all at risk. The concentrated animal farming operations, or CAFOs, that Mark discussed, are the sources of methane, water, and antibiotic pollution that make the packaged meat industry the source of 18% of annual CO2 emissions that keep the climate from cooling as it should. But we can take heart and develop hope based on Mark's comment that regenerative farming is a shovel-ready, no-regrets approach to reducing the negative impacts of the food supply while transferring carbon back into the earth at 1/2 or 1/3 the cost of the technological solutions that we've also discussed here on the show. Certainly, we'll need to craft combinations of carbon removal technology and soil restoration strategies given the crisis that we face. However, that can also put millions of people to work in the process. And the key is recognizing the value in restoring the ecosystem services provided by a healthy environment and rewarding the people who undertake this civilization-saving work. That's our farmers. Stay tuned for more conversations about regenerative farming and the incentives needed to displace industrial agriculture. And I hope you'll take a moment to share this podcast or any of the more than 490 interviews that we produced on sustainability in your ear with your friends, your family, your colleagues, and coworkers. Folks, writing a review on your favorite podcast platform will help your neighbors find us. You are the amplifiers that can spread more ideas so we create less waste. Tell folks that it can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or whatever purveyor of podcast goodness they prefer. Thank you for your support. I'm Mitch Ratcliffe. This is Sustainability in Your Ear, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.